At a basic level, R is just a calculator like any other, so I can input numbers like 1 or 1.1. I can also input them in scientific notation like 1e3 or 1 times 10 to the 3 or 1000. I can input 3e3 to get 3000. I can also use decimals in the scientific notation, so 1.1e3 would give me 1100, or 1.1e negative 3 would give me 0.0011. I can also use the capital E, like 1.1E3, but that's a little bit less common. Sometimes you'll see people use 1L with a capital L after it. That corresponds to literal and is referring to an integer. So 3L would be 3 the integer, 3.5L would give us a warning. Now, there are also many number-like quantities like infinity, I and f, or negative infinity, negative I and f. There's not a number, n, which corresponds to operations where there's no natural number to assign to it. For example, infinity minus infinity. There's na, which is not available, or the standard representation of a missing value in R. And sometimes you'll come across null, null. Null is actually something that's a little bit different. It's not a number at all, but it looks a lot like these and it gets confused with them a lot. Notice that RStudio highlights all of these. That's because they're special words in the R language. Like any calculator, arithmetic is defined between numbers, and there are several different arithmetic operations. So 5 plus 3, 5 minus 3, 5 times 3, 5 divided by 3. There's also 5 to the 3, which is denoted like this. Usually we don't put a space there. Occasionally you'll see this, but this is less common. There are also two others that you probably don't think about very often. They're called integer division and modulo. Integer division is 5% / 3. That's the number of times 3 goes into 5 as a whole number. So 3 goes into 5 exactly once with a remainder of 2. The remainder is the other one, the modulo. 5 modulo 3 gives 2. So for example, I can type in 5 integer division by 3 times 3 plus 5 mod 3, and that will give me the result of 5 back. Of course, arithmetic with special numbers is special, like inf plus 3 is inf. 7 times NA is NA, and that illustrates something about the NA. NAs are said to be infectious in R. When you do almost anything with them, the result is going to be another NA. So NA plus 1 is NA, NA up 3 is NA, and so on. R also has a number of comparison operators. So for example, if I type in 5 is greater than 3 and I evaluate that, that evaluates to true. Whereas if I had typed in 5 is less than 3, of course, I get false. If I wanted to check if 5 is greater than or equal to 3, I just put those symbols right next to one another. And similarly for 5 is less than or equal to 3. If I want to check if 5 is equal to 3, I can do it like this with 2 equal signs. And if I want to check if it's not equal, 5 is not equal to 3 with the bang operator or the exclamation point. R also has a number of built-in basic mathematical functions, like the square root, sqrt, of 9. I could have also done this 9 to the 1/2. It has the sign function, sign, so the sign of negative 3 is negative 1, whereas the sign of 3 is positive 1. I can round numbers with round, and I can round them up with ceiling, and down with floor. Floor may be a little bit easier to see with a number like 1.7. R also has pi and trigonometric functions like sine of pi over 4 or cosine of pi over 4. Obviously this is in radians. The tangent of pi over 4, and so on. You can see more by typing sine. It also has other transcendental functions like e to the x and log. E to the x is exp of 2. That's e to the 2. E itself is exp of 1, so there's no dedicated e in the language. The natural log is log, so log 2.7188282 will give me 1. That's log base e of e. If I want to log with a different base, I can also use the log function, but now I have to type in a base argument. Base is 5, and this works because log of 5 to the third base is 5 is 125. There are also combinatorial functions like factorial of 3, that's 3 times 2 times 1, which is 6, or factorial of 4, which is 4 times 3 times 2 times 1, which is 24, and binomial coefficients like choose 5, 2. In calculators, this operation is often called NCR, so here this would be 5C2. Like many calculators, R can also store values in variables. To do this, we use the assignment operator, which is less than dash, or simply read is, 5. So this assigns x the value of 5. A quick way to type in the assignment operator in RStudio is with Alt minus, or Option minus if you're on a Mac. Once I assign the value 5 to x, I can use x just like 5 itself. So x plus 1, of course, is 5. I can define another variable, y is 3, and if I type in x plus y, of course, I get 8. I can look at all the variables I have with the ls function, and I've defined two, x and y. I can remove variables with the rm function. So rmx removes the value of x, and if I try to use it in the future, it'll say error object x not found. If I type in ls, notice that the variable x is gone. I can remove all the variables using the so-called nuclear RM, which is rm list equals ls, and this will remove all the variables in my global environment. One last thing on variable names. As you make variable names, try to be descriptive. Your variable names can be more than one character. So for example, if you want to store something in a variable called year1, you may want to write something like year 1 is 10. This is often referred to as serpent case. Another convention is to use words that are run together, capitalizing every word except for the first one, like year 1 is 10. This is referred to as camel case. One thing you should try to avoid is using periods in names like year.1 is 10. This works, but the period in R typically denotes something very different than a mere name, so it's best practice not to use it. Lastly, and strangely, you can also use names that normally wouldn't work in the R language called non-syntactic names. To do this, you have to fence them in what's called backticks. This is the character above your tab button on your computer. So I can make a variable called year1 with a space in it, which normally wouldn't be allowed, but I can assign that to something like 10, and then of course I can access it in the future as year1. As I said, this really isn't a good idea, but you do see this occasionally in terms of data sets, so it's good to know that it's out there.